Hey guys, welcome back to the channel. Before we hop into today's video, I want to take this chance to thank the sponsor of this video and of the channel, and that's 0 Point Security. My friends over at 0 Point Security are putting together some really cool things when it comes to offensive security, training course development, and other training packages. If you are interested in checking out different topics like how to use C# to develop malware or developing command and control frameworks, then you should go over and check out my friends at 0 Point Security. The affiliate link will be put in the description below. If you're interested in checking that out, make sure to use that link because it not only helps my friends out over at 0 Point Security, but it also helps out this channel as well. And then I'm able to invest all of those earnings directly back into the channel and make the content that much better for you guys. With that out of the way, let's hop over right into today's video. Alright, welcome back guys to another Hack the Box starting point machine series walkthrough video. Today we are going to be tackling a new addition to the starting point series of machines on Hack the Box, and that is going to be Responder. So this one's a little bit different than a lot of the previous machines that I've covered in the past here. However, I think this has a lot of really cool twists and tricks that we can dive into. Yes. Let's just, go ahead and come over to the virtual machine and do kind of just, the basics that we have been doing for quite some time now. So we'll go ahead and we will make a directory called Responder. I have to spell that right first. And then we're going to put and then we'll cd to Responder. And we will do that. I'm also going to blow this up a little bit so you guys can see it. Maybe not that much. It's going to distort it. Okay, so now that we are in that directory, we can go ahead and we're going to kick off a nmap scan. So we're just going to enumerate what ports are open, except for this time, I'm going to show you guys how to do this a little bit more methodically. It'll speed up your scan times. You don't want to just be, scanning anything and everything. It's typically not best practice. So I'll show you guys kind of what I do. I'm going to go nmap or sudo nmap that way, just in case any of the scans that we run require elevated privileges. Sudo will go ahead and take care of that. So we'll do sudo nmap, and then we're going to do dash lowercase s capital V capital C. Dash lowercase s capital V capital C is going to run the service enumeration on any open ports on the service that's sitting behind that port, and then that capital C following that is also going to denote to run scripts. So that'll try to find what service is sitting behind that port, and then it'll actually run some scripts to try to further enumerate more information from that service sitting behind the port. So then we're just going to do dash capital T4. That'll speed up the scan just a little bit. It usually T4 is the speed in which most people kind of consider that you're not compromising results, but you're also kind of maximizing efficiency. So I go ahead and do dash T4, and then I'm going to do dash top dash ports, and then I'm going to set this to the top 75 to 100. In this case, I'm going to do 75 ports because the odds that, there's some port sitting on some non-default number is lower. It's definitely worth it to check, and we will run back through and run a full port scan. But just for some quick information, you can run nmap on the top 75 ports per se, and that'll decrease your scan time a lot. So we're going to go ahead and do dash top ports 75, and then what we'll do is dash VV for some more verbose output. And then we can do dash capital P lowercase n. That'll turn off the host discovery, since in this case we know that the target is alive on the network, right? So we can skip the phase of trying to figure out whether the host is alive on the network. Dash capital P lowercase n will handle that for us. And then all we need is the IP address of the target. So we'll just go ahead and copy that. And then we can come back over to our machine and we'll paste that right in. And typically you can save this to a file. In this case, since we're just doing this for some quick information, I'm going to go ahead and save it. But if you're working on this by yourself and you need to come back to this box a couple of times before you're going to go ahead and get it, I highly recommend saving the output of that scan. Do that with just dash lowercase o capital A and then the file name that'll give you XML output. It'll give you the standard nmap output. It'll give you greppable output. You can basically get any type of output that you want with dash lowercase o, capital A, and then the file name. I'm going to go ahead and kick this scan off, and then I will cut back over to you guys once it is done running. Okay, what's going on, guys? The scan finished, and we have some results here. So one thing that I actually forgot to mention before I went ahead and ran the scan is that you can do -- ports equal open, and that'll get rid of all this filtered garbage. It's right up top here. So that way you would technically, in this case, you'd only be seeing TCP port 80, which looks like it's going to be a web server. It looks like we have Apache running right there. And I'll show you guys exactly why I like to run that scan first and then kick this off in the background. So we'll go ahead and we'll run another port scan. You'll do nmap, same thing as before. We'll start out here with the SVC and then T4. And then what we're going to do, we also want to keep that capital P lowercase n. And then we're going to do -p-. And dash lowercase p is how you specify the ports. But if you follow it up with a second P or a second dash right there, it basically tells it to scan every single port. And that'll take a little bit of time. So we're going to run this in the background. While now we know that port 80 is already open, we can let this run in the background, and then we can also check out and see what's on the web server. So we'll just run that, and then we're going to output that file. Let's just do that OA, and we're just going to call this full scan. So we'll let this nmap run in the background. I'll open another terminal prompt so that can run in the background. But what we wanted to see was what was running on that web server. So what we can do is we can just do HTTP, since we saw it was on port 80, and then we're going to specify the IP address, and then we'll go ahead and hit enter. And then one thing cool or interesting to note here is that we're going to get a DNS probe finished, the NX domain error, which typically means that it can't resolve the name that it is trying to associate with an IP address. And what we can do, there's basically a local version of DNS on Linux machines, and it reads a file called etc host. So what we want to do is we can just edit the etc host file, and you can see that when we pull this up, oops, typed the password wrong. So when we pull this up, we have a couple of different IP addresses here. What we need to do is stick our target IP address in with a tab after it, and then this is the host name of the target that we're trying to reach. So it can't find that host name and resolve it to an IP address. So what we can do is basically manually force it to resolve to that target host name by adding that to the etc host file. So then what we can do, we make sure that our etc host file is saved. We'll go ahead and close that. And now if we reload this page, we'll see that it's actually going to resolve. And that's because of a very interesting quirk that you can do. You can serve multiple websites on one server, and it's denoted by the host header. So those are typically called virtual hosts. You'll see that a lot. And a way to get around that is you need to be able to specifically specify which host you want to reach at one IP address. When we just put in HTTP that IP address, it didn't necessarily know which host to resolve to. So if we use that host name and give it the associated IP address in the etc host file, we'll be able to pull up the website. And now that we can see that we have a functional website here, one thing that I like to do when I'm doing web application tests, the first thing that I do is begin to click around on the application. You want to be looking around, see if things are dynamically loading into the page, or if it's in a single page architecture where you have to click on different pages. It's only going to load the content one at a time. Where are parameters at? Input fields, just kind of identify any information that we can retrieve from the box. And you'll see actually we have a feedback form submission at the bottom here, which is all good to know. Those are all potential injection points where we might be able to throw a payload in at. I do see that we have the ability to change the language, and I want to draw your attention to this parameter that's being passed up here. So this is going to be passed as a get parameter in the URL. And you'll see this page. This is the parameter name. That typically indicates to me that it's loading in this page from some static file on the file system. That's usually what this kind of named parameter is getting at, and the fact that it reloads the entire page every single time you click on a new language is telling me that it's reloading the page based on the contents that it's loading from another file. It's not doing it with English, probably just because that's the default, but French is for sure, and we'll see that the same here with German. So one thing that I like to do when you see that it's like trying to read the contents of a file, or most likely trying to read the contents of the file, is we can just throw a couple payloads in here. And typically a lot payloads that are associated with this are either arbitrary file reads or file inclusion vulnerabilities. And that's essentially where we can read or see information from files on the file system itself. So on the actual server that's hosting this web application. And one, I guess we don't know whether it is a Windows machine or a Linux machine. You can always try etc password. That's a file that's going to be there every single time on Linux, or I want to say it's drivers system32 and then boot.ini is one that you can look for on Windows machines. But we'll see here right away, we have a C drive and backslashes, so that's going to be very indicative of Windows machines. And then we'll see that it is also running everything on the XAMPP stack. And we also now know that we're running, or that this web application is running PHP. So already have a ton of information to work with here. This is information disclosure in and of itself because it is telling us way too much information for simply putting in the wrong information into a parameter field. And you'll also see, this is extremely important, you'll see that it's showing us that the include method is called. If you remember a couple of minutes ago, I started talking about file inclusion vulnerabilities. And that is essentially where you can have code be included from elsewhere and then executed on the server, and we can potentially use that code execution to get a shell on the machine. So that's something that we can go ahead and try to build a path up to here. Okay, and now that we know that we are including some type of file and that we're going to try to build into this file inclusion vulnerability, one thing that we need to do is this application is being run from the web root. So it's not actually just going to read a absolute path if we get it. So what we need to do is we need to traverse back to the root of the file system. And how you do that is the same on Linux as Windows, but we'll just add a bunch of // beforehand. And the reason that we do a bunch is because you can't get penalized for going too far back. If you try to go back further than the root of the file system, it won't let you. So it basically will just disregard any of these // trying to go back if it's past the root of the file system. So by adding a bunch of these in a row, we can ensure that we get out of the folder that we're currently located in and get back to the root of the file system. I just do this, I add a bunch of these just because, one, it doesn't hurt, and in most cases, a lot of the times you'll find file inclusions, you'll be, several folders deep on the file system. So you save yourself a headache by just adding a bunch at the beginning. It'll never hurt. So what we want to do now, we're going to go after a file on the file system that's always there on a Windows machine. And that one is going to be Windows System32, and then it is under drivers, and then it is etc and hosts. Whoa, if I could spell. And sorry, I also made another typo. That's not systems 32, it's system 32. So you should have a bunch of // Windows system 32 drivers etc hosts. That's basically the same etc host file that's here on this Linux machine. It does the same thing, and it's basically always going to be there on a Windows machine too. So we can use this as a proof of concept to see if this parameter is being used to read the contents of a file off of the file system. And boom, would you look at that? So this is going to be the beginning of our exploit chain that we can work with to either potentially get a shell on the machine or read other information off of the machine. This is a fantastic starting point because this could be a potential entry point to the system. And, so before we get too far pushing along with this LFI or potentially RFI vulnerability, we haven't even gotten to that just yet. We want to go back, and we did let a full port scan run in the background. So what we can go ahead and do is come back and check it out, and it is finished. So we do get port 80 that we already know about. We do see that it is Windows 64-bit that we kind of already knew based off of the LFI vulnerability that we saw. Don't get a ton more information from that. We do see that they also have the Microsoft HTTP API open on 5985. Not a lot of things that we can do with that. And then there is also 7680, which looks like it's trying to fingerprint it as PandoPub. This is going to be something really bizarre open on here, kind of non-standard. I believe this is something like a file transfer program that's commonly used. So, kind of piecing some things together, but we can try to assume that this file transfer is going to be something like SMB equivalent there, since we are running Windows. That might be something that we want to pay attention to. So we do know that there is going to be something along the lines of SMB-esque technology open on this Windows machine. And we do have a local file inclusion vulnerability at the least. Potentially remote file inclusion, but local file inclusion for sure at the least. One thing that we can try to do is we can try to authenticate to the Windows machine, and with this local file inclusion, what we can do is essentially use a tool in the Impacket toolkit to capture NTLM hashes as we try to authenticate. And without going in too much detail, I could make an entire video on NTLM as an authentication method, but to keep it very high level, essentially NTLM is going to be essentially like a Windows specific authentication protocol, except for it's going to be utilizing, it passes a password hash, or the user's password hash, which is basically a unique string that's condensed from the actual password that the user supplies. And if you can get that password hash, theoretically you could crack it, or you could replay it to authenticate to the system. And basically what we'll be doing is, using this local file inclusion vulnerability to get that password hash and capture that hash, but we will also be needing to use another tool. So if you do have the newest version of Kali installed, you have your Kali VM up to date, what you can do is you can just simply run locate responder.py, or, sometimes you might not have it under .py. In this case, I probably don't. It's probably going to be installed from Impacket. But what we're looking for is to make sure that we have Responder installed somewhere, and we do. Okay, so we'll see that we have Responder. There's a couple things that we're probably going to need to make sure that we have enabled in the configuration file for Responder, and that's going to be etc responder and then responder.conf. So let's go ahead and check that out really quick. So we're going to sudo subl, and then we're going to do etc responder tab to complete that. Open this up, and we're going to make sure that we have SMB as checked on. So this is basically just going to make sure that we can capture SMB traffic, and that looks all good to go. Okay, so with that, we can go ahead and close out of our responder window. The one thing that we're going to want to do now is configure responder to basically just sit as like a proxy on our host. It's just gonna like man in the middle our own requests, and we're just kind of gonna hang out with it on, and we're gonna test a couple payloads on our local file inclusion and see if it can sniff anything out for us. So in our case, since our Kali is up to date, we can just type responder. If you did choose to pull responder down from the GitHub repository, what you will need to do, you'll most likely likely need to run that with sudo privileges, and you know what, we will just do it anyways, even though it's installed. And then you're also going to need to specify Python 3, and then responder.py is going to be the file that you want. So now that we have that set up, we're going to want to do -I for the to specify the interface that we want to listen on, and we are on ton 0 is actually the VPN interface that we're going to be utilizing. If you have a couple like broken VPN connections, you might have a different ton interface. You can always just, kill your VPN, restart it to check that. And I'll show you guys really quick actually how to check that. And what you can do is you can just do IPA, and you'll see all of your network interfaces. Ton 0 is going to be ours in this case. Basically, ton 0 stands for tunneled connection at like a super high level, which is like a VPN. So let's go ahead and bring back our responder command here. We're just going to do -I ton 0. So that's going to be up. You can see we're pretty much just it's kind of just going to hang out. It's just going to be listening for connections, and we're just going to, it's just going to chill there for us for right now. Now what we want to do is we want to take this same page and we want to try to specify SMB share connections. And this is where we're going to try to take this from a local file inclusion to see if we can maybe escalate it to a remote file inclusion, where we're going to be utilizing that responder proxy that's hanging out behind our browser here. And what we're going to essentially be doing is we're going to force this page, or this web server essentially, or web application, to try to request some file share via that PandoPub kind of SMB-esque file transferring service that's on the machine. What we are hoping will happen is the responder is basically sitting with a bunch of evil payloads, and if something reaches out trying to grab that payload, it's going to capture that password hash being relayed in the NTLM authentication method. So it's basically going to trick the target machine here to try to give us its NTLM authentication credentials, and responder will be able to extract the password hash from that NTLM request. Again, that's not like technically detailed 100% what's going on. I'm going to try to keep this very high level, as a lot of NTLM authentication methods can get slightly convoluted. So keeping that at a high level, that's a good way to think about what's happening. So we'll come back over here, and you can see this is where our responders hanging out, but what we want is our IP address. So what we need to do is we are going to do IPA like I showed before, and then we're going to grep for ton 0 to grab our own IP address, and you can see we're at 10.10.14.12. So we're going to copy that, and then we'll get rid of that tab, and we'll come back, and we did //, and then our own IP address, and then you can enter in some garbage file here. So what we can do is like test file, or this is actually going to be a share name. This isn't a file, but let me change that so it makes a little bit more sense. This is essentially just some phony share that's set up after our IP address, and what we're going to hope here is that this local file inclusion is also vulnerable to remote file inclusion, and then by requesting this garbage share that responder is technically listening for, this machine will try to connect to our Samba share that we are forcing it to do via the RFI vulnerability, and then as it tries to connect to that malicious responder proxy-esque tool that we have set up, it is going to capture that hash of the user that is running the web application underneath this server. So what we can do is then we will then request this. You can see that we have some errors pop up. That's probably to be expected. But what you will note here that is exactly what happened. So what you'll see is that we have the NTLM hashes set up, and this is what it looks like to be the password hash of the administrator user. So we would actually, now we actually know that the web application is running on the operating system as the administrator user. And you can see that right here. This is going to be the username, and that's typically denoted by the domain / the username. And then you'll also see the password hash. So this is going to be the username, the domain name, and then we see the password hash following it. So now that we have the password hash, what we're going to want to do is move into cracking that password hash, and hopefully we can get it into clear text. So maybe we can just, straight up authenticate to the target machine with a clear text password. If not, there are potential avenues to try to replay this password hash and authenticate to another system just by kind of pushing this hash onto the machine, but that's, kind of a last-ditch effort in a lot of cases. So let's see if we can go ahead and crack this password. Okay, so the first thing that we're going to want to do to crack the password, or the password hash rather, is we are going to want to put this password hash in a file. So what we can do is we can just do echo, and then we'll just paste in our password hash. Basically make sure to put that inside quotation marks, and then we'll use the redirection operator to send the contents of echo to a file. We can just call it hash. You can use hash.txt. I typically like to just use hash, so we will just call that hash. And then let's actually move hash into the responder directory, and let's cd into the responder directory just to keep everything a little bit organized. That way we are all set up here, and we can get rid of this. So let's go ahead and cat hash just to make sure that we have contents there, and we do. Next thing we need to do is we're going to need to basically decompress the RockU word list, which is basically just a real common password word list to run against this hash that we have. So we're going to use gunzip, which will basically, or gunzip if you like to pronounce it that way. It'll basically decompress the RockU word list that is by default in Kali. You can find it at this location that's on screen right here. And I'll blow this up a little bit so you can read it a little bit better. But we're going to unzip this, except for we need sudo privilege, or we need to do this with sudo. So we have root privileges. This is going to basically decompress this. That way we just have it in a text file. And now that that's all set up, what we can do is we can use John the Ripper. Is a common and quicker tool that we can use to try to crack this password. So you do that just by typing John, and then the first thing that you're going to need is you're going to need a word list to run your hash against. And you do that by doing -w and then an equal sign and then the path to the word list. So that will just be user share, just like we typed in before, word lists, and then rocku.txt. Whoops, that would be .text, and then we're going to run that on hash. So I will go ahead and run this. I'll come back with you guys in a couple minutes. I'm going to cut this up just because I imagine even if it's within the first couple thousand lines of RockU, it's probably going to take a couple minutes to run. So I will go ahead and run this, and I'll cut the video back to when we hopefully have a match, or if it iterated through the whole word list and we need to explore another path. Okay, and as you guys will see here, we actually were able to crack the password hash for the administrator user with that technique. So we get this password, which is badminton. I think I pronounced that correctly. But now we have both a username and a valid password for the administrator user on the box. And if you guys come back over here, we can use, you'll see based off of the contents of the nmap scan, but basically what we can do is we can use a program called Evil WinRM, and that will allow us to authenticate to our target system with our credentials. So what you'll see is we can do evil, and then we'll just do -winrm, and then all you need to do is -I, and then the actual IP address of the target that you're trying to connect to, which I will need to come back over here and grab that IP address. We'll paste that back in. Now that it has that, you just do -u for the username. In this case, it's the administrator user, and then -p is the password for the user that you're trying to connect to. And in this case, it was badminton, or badmin on, I guess. So all we need to do is start that up. Basically, we are authenticated to the machine as the administrator user. Now, we can try to look around for the flag. We'll try to just head back a couple directories here. I'm just using dir to list out some directories. Let's see if we go back, or maybe if we cd into desktop. That needs to be spaced, and then do a dir here. Don't see anything. Okay, so maybe it's not on the administrator, in the administrators folders. It's typically in like documents or desktop. I didn't see it in either. So let's go ahead and see if what else we have. Okay, so it looks like there's another user, which is Mike, which we should just be able to view his contents as well, because we are the admin user. So if we go ahead and look here, okay, it looks like he only has one, so maybe it's not in Mike's either, but, oh, yes, it is in Mike's. Okay, Windows has the equivalent of what the cat command would be, and that is just going to be type. So then if we type in, we just do type flag.text, you'll see that we are able to get the contents of the flag. And that is basically the attack path for the responder box. I will link a couple of different resources in the comment section below that do a little bit more of a deep dive, but a deep dive starting from beginner level on a lot of the different topics that were covered in this machine, because I do think this machine is slightly more difficult than where they place this in terms of the actual starting point track that it's placed under. But thanks again for watching, guys, and I will catch you again in the next walkthrough.